Hello everyone, welcome to my channel. So today we are going to do Leetcode line 75 question, reverse linked list. So let us first read this question, then about the constraint, then examples, and finally the coding part for the same. So let us go ahead that how we are required to do this question. So here, 1 minute, I need to check actually. Yeah, okay. So given the head of a single linked list, reverse the list and return the reversed list. So the thing is that we are given with the head of the linked list. This is the head which is being given to us, and then we are required to return the reverse portion for this linked list, which would be something like this. Means this is given and we are required to do this. So this is basically the standard question, an easy level question, and same we are required to do here also. And as per the constraint, but as it is a linked list, so it's somehow it wanna be order of n solution only. And accordingly, time the constraints are also given to us. And the value could be negative as well, but value doesn't matter to us. Only thing is that we are required to access the memory of those nodes and required to reverse the same. So that's the thing which we are required to do here. And the linked list can be reversed as I iterated recursively. Could you implement the both? So let us try with both of the implementation. Now comes the part that how we are required to implement the same. So let us first go ahead with the recursive way. Okay, so for recursively implementing the same, how we are required to go ahead is, see, when we are required to check for the recursive part, right? So for that part, we are required to check, see, in recursive, it would be like calling of the function again and again, and then backtracking would be there where the actual linked list would be formed, means actual backtrack linked list would be formed. See, the thing is like, if it would have said that just directly print that reverse linked list, then surely it would have been like function whatever is there, and we would have passed the head and the head next. Not the head next, only the head for the same, and then see out the head next. While doing the same, is at the starting, we would have done 1 minute. At the starting, we would have directly done see out, head next. Or what I'm typing. At the starting, just see out the head which is being there, head value basically, and then call the function which is there and call that function by doing head next. And then while backtracking, head next, whatever value is there, that thing we are required to bring. So if we would have done like this also, so while backtracking means when it would have reached at this point and then it would have been returning. So at that point only it would have been printing 5, 4, 3, 2, and 1. And then whatever base case would be there when it gets hit, then surely it will exit the function. So that's the thing which we could have been done if it would have been like just print the reverse linked list. But now they have asked us to modify the linked list. So for that purpose, we are required to have some extra variables, and according to that, we are required to modify the solution as well. So for that purpose, what we are required to do is we are having the head, right? And we also require a tail as well. In this tail only, now we will be storing means whatever we were doing that see out part after the function, right? So now in this tail only, we will be storing the reverse part which would be there. So that what a tail would be helping out with. And even the thing is that in linked list, we are required to handle the case of that if head equals to null or if head next equals to null. In both of the scenario, we would be required to check that how we are required to reverse the linked list. So that's why these are one of the base case for a recursive solution. So now let us go ahead for the coding part for this recursive solution. Then I'll discuss about the iterative one. So let us go ahead. So here I have already coded for the recursive part just for ease of explanation. not just ease, but for the fact that it could be explained in much faster manner. So here's the same. And I'll also show you the recursive tree, that how the solution would work. That would be much better. So here these are the base case. If head is null or head next is null, then we are required to return directly head. That simply means that if null is given to us or only one node is given to us, one, two means basically a single node is given to us, then we will be directly returning head. And this also acts as the base case for a recursive function. Now comes the next part. This is rest head. Here we are storing all the all that particular portion, means we will be passing it as 1, 2, 3, 4 every time, like all this. And then this is that resting. Whatever earlier we were just printing, right? Now, when we will be backtracking, at that time, this will be stored in our rest tail. And then, as we are now modifying the linked list itself, right? So because of doing the modification in that linked list, now what we are doing is we are just making that rest tail next equals to head, so that now the links are being reversed. Means earlier this 4 to 5, it was like this. Now it would be something like this. So that's what we are doing here. And our head next will become null. This we are doing just for breaking this particular link and then returning the rest head, because now our rest head is basically at this, but not at this point. Our rest head would be at this point, because now this would be our new head for this particular portion of this whole linked list. So that's the thing. Now this was the coding part, but let me show you the dry run for the same, for the better explanation. uh so here's the same. So here how the things are. First, reverse head next, the function which is there. Now in that function, what we are exactly doing is, means it will first go to 1, right? Then to 2, then 3, then 4, then 5, then 6. Then 6 would be that null, right? So when it reaches at the 6 point, then here the base case reaches as head next equals to null, right? So because of that, it will revert back to its parent. And at this point, our recurrence head equals to 6. And at this point only our rest tail would be equals to head next, that is equal to 6. And rest tail next would be equals to head, that one be equal to 5. And head next equals to null. And then 5 next, because of this head next equal to null, that 5 next will become equals to null. This will be something like this, right? And then now 5 returns back to its parent, that is towards the 4. And when it returns to the 4, so at that particular point, and then after that, as it returns to 4, right? So at this particular portion, a recursive head is equal to 6, and then a recursive tail is equal to head next, that is now it is equals to 5. Until this portion, now our links has been reversed, and our recursive tail next equals to head, that is equal to 4, and our head, that means it is now equals to 4, right? So heads next now becomes null. So now 4 next becomes null, and 4 next was earlier 5. Now it is pointing towards null. So because of all this only, all the links has been reversed. Basically, links are getting reversed because of this recursive head and recursive tail. So the thing is that recursive tail is now pointing towards the heads next, that is 5, right? And recursive tail next is pointing towards the head. So because of all this only, earlier the links were from left to right, now the links are from right to left. So that's the thing, it will carry forward towards the starting of the linked list. And this is what we have coded at that moment. So this is how the recursive function will be working. Now let us go ahead for the iterative function. But before that, Let us first think that how we can do it iteratively, then we'll go for the coding part. Here's the iterative solution for the same. So while doing for the iterative part, what we are required to do is we will be first checking that list current equals to head, is not checking but directly assigning one current node with the same, then one previous node and then one next node. Basically, we require three variables which would be there. One would be pointing to the present, one would be to the previous, and one to the next. So that's why we require three no what we say three nodes variables which would be there. And now next what we are going to do is, now here the actual thing comes into picture, because earlier it was recursive, right? So we were calling the function and that was by itself playing the role of the loop. But here we require a loop for doing the same. So here, while current is not equals to null, means current still exists. Till that point, we will be checking that next equals. We will be making our next to the current next. Means here is the current, and now current next is this. Then previous equals to current. We will be modifying the this and then making the current equals to next. So now current will be pointing here and previous would be here, and even current next is also here at this particular moment. But this loop goes on until our current still exists. Because our current moved at this point, so because of this only, now we are required to check that it is the last point or is something else also there. So because of that only, we are having this. And then our next will become current next. Means now it current next would be here, and we will be whatever was there in our previous, now that will be becoming our current. So that will be now our currents next. So at this point only, we are basically reversing our what we say our nodes here. So like this only we will be moving ahead because of this while loop, and at the end we will be returning this previous, because after the loop current will be pointing to the null, right? And the previous will be the new head. So like this we will be going ahead with the iterative solution for reversing the linked list. So this was all for this particular question. And the thing is that an iterative solution is order of in time complexity and space complexity, but our recursive solution is order of n time complexity, but order of n space complexity if we are considering recursive stack as well. So yeah, this is all about this question. If you have any doubt, you would comment that out. And yeah, this was all. Thank you.